merge function. Merge combines two or more maps or objects into one result. When the same key appears more than once, Terraform keeps the value from the later argument. That overwrite order is the whole mechanism. The outcome is predictable override behavior without rewriting the full object by hand. The practical use of merge is separating defaults from exceptions. The first map carries the baseline. The later map carries the local override. The outcome is cleaner code because shared values stay centralized while environment-specific changes stay small and visible. Terraform documents that merge accepts an arbitrary number of maps or objects, so this pattern scales beyond two inputs. Merge matters when a resource expects one final map, but your design produces that map in layers. AWS resources such as AWS SSM Parameter accepts a tag argument, and the provider's current documentation shows the resource in the latest AWS provider line. The mechanism is simple. Assemble a simple tags map before the resource block consumes it. The outcome is one deployable object with shared governance tags and workload-specific metadata applied together. Merge can accept objects as well as maps. Terraform states that if the argument types do not match exactly, the result becomes an object whose attribute structure reflects the merge result. The mechanism is type expansion during evaluation. The outcome is that your final value may contain more attributes than any single input, which is useful when composing structured data, but dangerous if you assume a narrow shape. Merge is not recursive. If two inputs contain the same top-level key, and that key holds another map, Terraform replaces the entire nested value from left to right. The mechanism is shallow overwrite, not deep reconciliation. The outcome is that nested settings can disappear if you assume Terraform will combine inner keys automatically. On a submarine, a control panel can look healthy while one overwritten settings routes the system into the wrong state. Nested maps behave the same way. A top-level green light can hide a missing inner value until the system is under load. The safest pattern is ordering inputs from least specific to most specific. Put global defaults first, environment overrides second, and one-off resource overrides last. The mechanism is deterministic precedence based on argument position. The outcome is a configuration model that reads like policy escalation instead of accidental collision.